Oh yeah, we saw him at the
Okay.
cafeteria.
So Anshul, can you hear me? Fine.
Yeah, I can hear you.
Oh, okay. Sorry. So, um, I'm gonna quickly show how to run star CCM in Badge. It should take, I think, 4 minutes, 5 minutes, and
You could turn
well,
on the lights. The lights
um,
on this side. A little more dim.
so on Scratch, Uinta, under my directory, I posted uh, the star CCM batch files that you will need, and this applies to any, well, whatever I'm going through is going to be specific for star, but you can apply to any other program you're running. So there are the files that I'm just going to uh, use and show you how to use. So this is just a job file. You will need to create it on your own, but you can use that as an example. Then the macro file I wrote just for use of star to change the number of processors. As Anshul knows, and some star people know that star in batch doesn't run well on 8 processors, but only on 4. So this takes care of that. And then the star nodes is basically what I'm gonna be, what I assume you gonna set the aliases to and all those things, and everything is described in the nodes PDF. So if you look at that, um, and you can feel free to take these, and these are just on. It's a little slower, but everything is described. That I have all the variables that I have set, and all the paths, and how to basically go about this is all in that PDF. It's gonna differ a little bit from what I'm doing here, but either way will work, and you can choose what's best for you. So this is um, there is no set way of doing things. So I'm gonna use, for example, I'm gonna use um, so I'm right now I'm in the documentation for star CCM 502. And under validations, I'm gonna use the case for annulus, just the first one, and I just pick that. So I'm gonna just take the simulation file, is all set up, ready to go. So I assume that like your simulation or something, you have it set up, got proper boundary conditions, uh, or the boundary conditions that you think right now that you want to have. So I'm gonna copy that guy um, to my the tutorial directory which I have. Where is it?
Star CCM.
Oh, here it is. This is the a little slower. So right now there is the file. So the other two files that you will need to start this, I put them under the star CCM uh, batch files. So I'm going to copy the annulus.job file um, back to the directory, and the pp and macro file, which you will need to use as well. You may or you may not, well, it depends, but if you want to run a little faster, I would suggest of using it. So I start out with um, 3 files, and to run star, to set up your case, it's always recommended that you set up your case not on the head node like Charles was saying on Wednesday, but rather on an interactive node. So to get an interactive node, you do the q sub, you do command q sub minus I minus capital X. So capital I for interactive, capital X for X11 forwarding, and um, I'm gonna request one node and 8 processors per node, and you can throw in wall time in there for if you want to go really quickly. I think maximum, I don't know, for Unity is it 12?
Yeah.
12 hours. I'm gonna request it for right now for 15 minutes. Well, let's do 30 just in case. And minus a uinta, and you can set up an alias, which I set up in my bash file. You can do it in alias file, but I set it up in my bash. So if you look at your files, ls-la, oops, in your home directory, I don't want to go away from this guy. In your home directory, your bash rc file, and right there I just set up all my aliases, and this is one of them. So I don't have to type it all the time. I just type in q sub 1 and it works. But here is the whole path, and hopefully we'll be able to get a node. Okay, so we can do qstat. I think might log off. I requested a couple nodes. Sorry, so this don't.
You've got one.
Yeah.
You could SSH into that node from the
Yeah, well, I'm already SSH there. So, I just wanted to kill one job. And to check on a specific node, if you want to check on the job, also qstat. So if you use qstat minus f and the job number, you get the list of the directory it runs from and all the when it starts and all that. And I'm just trying to figure out which node. So these are the nodes it runs on right now. And then stop me if I'm going too quickly. Just talking blah. And this is one of the commands. If you want to delete a job and you know something is going wrong in the job, it's somebody to use the qdel command, which also Charles mentioned on Wednesday. So I'm just going to delete one of the jobs. And it may take a while.
A quick question.
Uh-huh.
Can I rerun a job? So can I just kill the job in that node, set it some things up in that case, and then rerun the job in the same node?
No, not in the same node, not in batch. So in batch, you can do it interactively, but not in batch. So you can do it this way. So right now, since I killed one of my jobs, this job went on. So if you do it interactively, then yes. But if you do it in batch, you are never guaranteed you're gonna get the same nodes, or if somebody submits a job in the meantime, you don't know. So you may just have to wait. If you notice you have bad settings, which happens to us all the time, or you set wrong boundary condition, the job just dies, or there is no point of running, you kill it, reset it, and so now I'm on a single node, and so now
Look at you! You got all these nodes.
who?
You.
What, me? Oh no!
What, me? What's going on? Don't worry, Anshul's on there 3 times too.
Oh yeah, Anshul, you are the bad guy too.
Just a minute, I just want to interrupt you, Michael. Thing is that for running a test case, I just want to let people know that they can run interactively if they want to check whether their settings are correct or not. And a small case, so it's better to go with interactive running. And in that case, a few days back, Martin told me that if we want to run like on suppose 4 nodes, so the master node from which we are launching our starccm plus, in our machine file we have to delete all 8 processors of it. We cannot use any processor. So we will, if we have asked for 4 nodes, and if we launch from 1 node, then we can use only 12 processors. That means 4 each of the 2. Otherwise, whole updraft is getting very slow.
Oh.
I mean, previously we used to just delete 4 nodes. I mean, if you are running interactively, previously we are just used to delete 4 processors per node, and we used it. But now, from the master node, we have to delete all 8 processors.
You have to delete all 8 processors from the head node, from the master node.
Yeah, from the node which we are logged in. I mean, as soon as we suppose we ask for 4 nodes, we get a node. like updraft some 75 or 82,
Uh-huh.
this kind of node. So if we launch our starccm plus from that node, then we have to delete all 8 processors
Oh,
of that node from the machine file.
if
And we
you
can only use other nodes.
really, because
Yeah, I mean, this was the issue a few days back, and I discussed today with Martin and everyone, and we figured out that if we delete all 8 nodes, then interactively we are not using much memory of updraft, and whole updraft is not, full cluster is not getting slow.
was it getting slow? I didn't know.
Yeah, they told me they killed 2 of my jobs because of that.
Oh, okay. Oh, well, good. So, I didn't know that. I think I will, because I submit a job and now I'm gonna show. So I submitted, I did the interactive node and then I SSH to that node. Is that what you did too or no?
Yeah, I did that too.
And they told you no.
Yeah, I mean, if we are using a machine file, then if we are running interactively.
Oh, in machine file. Okay. Oh, sorry.
From machine files, we have to delete all the 8 processes of this node on which you have SSH.
Okay. Well, I'll change the PDF file to reflect that. For those of you, I don't know if you understood that or not. But right now there is no problem with that. Sorry. Yeah. So thanks for that, Anshul. So you submit an interactive job, but so this went through. But one thing you don't want to do is run the starccm right on when you submit the job. What you want to do, and this is for speeding the, just because of the forwarding, the X11 forwarding, you need to SSH into that node. So right now I requested a node and I got up 238. So it's an interactive node. So if I check on the, oops. So if I check on jobs, there is, this job has that updraft 238. So now right now I'm going to SSH to that node. And you need to put your password. So now I'll go into the directory where I have the files. And from here I'll launch starccm. Once you are SSH, you never want to run from the QSA, from the interactive node. Okay, so, well, now you are on interactive, but you are SSH into it. So now I'm going to open the file, and you can either run in serial, parallel, doesn't matter, but if you want to run in parallel, you do parallel power session, run all processes on local host, and you select 8 processors. So it uses, each interactive node has 8 processors, as Charles was saying on Wednesday. And then you can go and browse the, get the file you want, and now you can just read it in. Or you can just do serial, doesn't matter. But for bigger cases, well, if you do meshing, like Anshul was saying when he sent out an email, meshing for starccm is a serial process and for any other software, so you don't want to mesh in parallel, it's not going to speed up anything. So now that the case is read, this is how I go about setting up simulation. And first time through, I would suggest you do it on a small simulation, and then in the future you can reuse that for a larger simulation. So as a first thing, I'm gonna start a macro file. So this macro file you will need when you submit it in batch. This macro file is one of the ways you can change settings on the before you submit the job for your simulation. So if you want to change a time step, or if you want to change saving settings or anything, you can go through a macro file, and I'm going to show you a few steps, and you can do this for more steps, how to customize your simulation so you never have to open the simulation again. So in the macro file, I'm going to start recording, and I'm just going to call it macro.java.
Why is start avoiding non-blocking communication?
Oh, that's start with what? And,
Yeah, you don't want that.
start will avoid using the integrate. Avoids using non-blocking. You wanna use blocking.
You want to use
blocking all the time.
non-blocking. You want to
No,
use
you wanna-
asynchronous. You want it to be.
You-
You want the data communication between the partitions to be asynchronous. You don't want to wait for every partition to be ready.
When you are, yeah, that's if you have, that's true. If you want to speed up performance, that is the case. However, if a part of your simulation depends on another part of simulation, you need to use blocking communication.
If it depends on another.
If it depends on another part in the simulation. So if one part depends on another, like in the time steps, if you do different time steps, but
in certain
within. So I don't know about that one,
in
and
certain steps it will use blocking.
Yeah.
It should use blocking,
but
but
I don't know
during the
why it
solution-
uses this one. No, I never. Anshul, do you know the answer to the non-blocking communication question?
Pardon me, I was out of office for 2 minutes. And
Oh,
I had
okay.
no answer.
Yeah.
Okay, now-
Yeah, you are good.
But see, that's
Yeah.
but that's a star CCM plus engineer question.
Yeah,
not-
so that's
not
yeah.
something
I don't
we can
know.
control.
Yeah,
No,
so
can we is there a setting that we can?
there.
That's what I'm asking.
No, I mean
I don't
this
know.
is this is how they
Question,
use.
Maybe I can help.
Yeah.
Yeah, so the question is about how when you start up star CCM plus and you say you're running in parallel. there's a
Ooh,
couple
I know why.
messages that say star CCM plus will avoid using non-blocking communication.
And here it is.
And
So
so
I-
Tony's wondering why it's using why it's using blocking
There
communication.
it is.
If we can,
Yes, you can.
if
There
we
it is.
can avoid using it. Warning the
I
master.
don't know. I mean,
Is it-
I never, because
Yeah, I think it's because the master.
I haven't seen that.
Yeah, because the master and the first process shares the same core. So the master node is the zero process, and the first process is the core process.
No, but
I-
this is only for I/O performance.
Yeah.
It doesn't. When I run it in parallel, it doesn't do this way. When I run,
Oh, so when you run it in actually in parallel.
yeah, it
doesn't-
on a local.
Same
on
thing
a,
I was saying. I have never seen this.
Oh,
thing
okay.
Because
Yeah,
I usually run in parallel.
Yeah, it's
Well,
a
is it-
setting maybe.
Isn't
It
this
could be.
related to what Anshul was saying though? I mean that you have to delete UP238 from the machine file, otherwise it's going to be using this asynchronous, or it's going to be using blocking communication.
Could be.
So if you deleted UP238 from the machine file, star CCM plus wouldn't be using the master process and a worker process on the same core.
Yeah.
I mean, it will use that 238 just to command all other processes what to
shouldn't
do.
Okay.
matter, it shouldn't matter.
Nothing else.
So let's do this.
And also tell them it's not good to use double negatives in their sentences, like avoid non-blocking. It's if they can change that to like
Let me see.
They're
yeah,
engineers.
it's avoid non-blocking.
At least it doesn't say avoid not using non-blocking.
Oh,
We'll try our best not to
that would
avoid
be
not using
Anshan
non-blocking.
messing with the code. Like, what's that print F line or something? Anyway, I was just
Mhm.
asking if we can, how we can change that. That's it.
Oh yeah, you can't. Well, it doesn't work. No. So this is what Anshul was saying, that you may need to remove the node you are on, that you are running, from your machine file. But for this guy, and I'm gonna go back to 8 processors.
But if you are just using one node, then you have to use that all in processes.
Yeah.
I mean, in parallel. You
So
cannot delete anything, otherwise it will not run.
so I would have to request
Like serial only.
two at least 2 nodes to do that.
You're also doing machine files, like, right?
Machine files?
Or are you just running on one node so far?
Yeah.
No, I will do. Yeah. So no, right now I'm setting it up. So
You do have to use a machine file, but if you look at it,
You
all
have
it
more
says is the
nodes.
node name 8
Yeah.
times. So in the case of using one node, you can't specify, oh, I only want to use 7 processors, and then use one processor for the master for
yeah.
the main controller.
That's not the question again. The
Yeah.
question is that if we get 2 nodes on updraft,
you wanna.
you're gonna show us that.
Yeah, so you reduce the number of, you do 4 based on what I was, not what just Anshul said.
Why you want to do 4?
Because it slows down if you use 8.8. So if you use
depending on what type of problem.
on any type of problem. Star just, right now with the memory management, Star doesn't support 8 processors per node, it slows down all the problems. So you never want to use 8 processors per node with Star, because it actually degrades the performance of your degrades the
So if
performance.
you're doing 8, it's better to do it on one node. If you're doing 16,
You
then
have to do 4
4
nodes, yes.
Huh.
So that's how it is. Yeah. So anyway, so the first thing, and I'm gonna go do macro file, and I'm gonna start recording the macro file. I'm just gonna use the one that I already have. That I started. So any command that you click, it's gonna be recording the macro file. So the first thing. Okay, so one thing, how depends on how you want to do run star, and this is totally up to you. But one of the things that I like, how I like to do it, is change the stopping criteria. So right now the stopping criteria are set to 100, and I don't like to do that. I don't like the simulation controlling when it's going to stop. I like to control it in my macro file. So I'm gonna turn that off. So right now the stopping criteria is disabled, and in the macro file and I hit it twice, so it shows the false, true, false. So we can later on edit the macro file and delete these two lines. The second thing that I always like to do is set up an autosave. So as your simulation is running in batch, you don't want it to just run. You submit it once, and then you don't want to wait for the final file to finish. Something happens, machine crash or anything. So in the meantime, you want it to save incremental files. You know, after, let's say, every 2, 4, 6 hours, or well, 2 hours may be a little overkill, but after 6 hours and then 12 hours. So depending on your, if it's transient, you may need to change. You may want to use time step or delta time. This file is a non-transient file, so it uses iterations. So I'm gonna set. I'm gonna enable the autosave, and I'm gonna say every. This runs pretty fast, so I'm gonna say every 100 iterations I want to save a file. For your simulations, you wanna figure out what the number of iterations or number of time steps is, so you can save it every 6 hours or so. 6 hours of simulation time, or how many delta t?
Saves different files, or just overwrite the same file?
It saves different files. There is a function here, autosave batch run. So there is the maximum number of autosaved files, but it seems like anytime you start the starccm interface again, it resets itself, so it never saves only one. It keeps saving one, so it saves maximum three files within each instance in batch. So let's say you were saving every 2 hours, and you say you want to keep only 3 files. It will keep the 3 files within the 12 hours, but then next time you start your another batch job, it's gonna put another 3 files, so it doesn't recognize the old 3 files. So that's what I noticed.
If you put 0 here, it will keep 1 file. If you put 2, it will keep 2 files.
If you put 0, it keeps all of them.
Yeah.
It keeps every single one.
Every single file.
Yeah, so, and that's what you want to do. And so that's what I prefer, I put 0, leave
All
0, and it keeps all of them, and then I delete them manually. So that's perfect. I don't like using autosave batch runs because I'm going to show you. You can use this if you want. It's up to you how you do it. But autosave batch runs is exactly for this purpose, that it saves. Anshul, are you there? I think the computer went to sleep. Oh.
She's not back in.
Oh, I think gonna say. So it will before it exits, it saves the files. But I'm gonna show you how to do it in your batch file, in your macro file. So I don't like to have this setting on, and I like to control it myself. So this is it, and then in the macro file it showed the set trigger frequency. So later on you'll be able to go there and actually change this number to whatever you want. But you want to have that command there, so you can go and just change the appropriate numbers. The other thing that I like to do there, so right now everything is set up and you have the frequency there. Now all I'm gonna do, and this is what the step where it can cost you a lot of time if you have a big simulation, but you only do it once for small simulations, so for this simulation, and then you can repeat the command for all other simulations. So I'm gonna just take one step. I'm not gonna say run, because run goes up until your stopping criteria. Since I turned off the stopping criteria, the simulation would never stop. So I'm just gonna click step. So it does one iteration, but what it did in the macro file, it created this little macro that star uses to tell you how many steps. So we can go back in and say, I want to run instead of 1, I want to run 100. Okay. And now the last thing I want in the macro to have, I go to File, Save As, and now I give it a name. So I'm going to give it final.sim name, and it's up to you. And now I save it, and once again in the macro file, it created that command to save the file. So instead of using the auto batch run stop, the auto batch save things, I like to use this. And then I can control the name of the files and whatever. So I want to have star to do as little things as I can in terms of, so I want to have as much customization for my simulations as I can in my macro file. So now I'm just going to quit the simulation since everything is set up. And it created these log files, and I'm going to just remove those for now. And it also created a macro file. So I'm going to go inside of the macro file, and you can add, so these two lines were created there for when I accidentally hit the button twice, so I'm going to delete those. And here is the autosave. It's 100 right now. I'm going to let it be 100. And then when I iterate, here is the step. So these files, these residual plots, so these were to create the plot for, the interactive plot. But when you run in batch, there is no X window. Okay, so you can't.
So this will cause an error?
It will give you just a warning error, but that's it. It won't do any. I mean, it won't be able to plot. It will just, I just can't plot. So that's it. So you can either leave it, and if you are unsure, what commands go with that, you can leave it, or you can delete this chunk where it says residual plot 0. So anything with plot 0, you can delete, and basically it doesn't affect the file. Okay, so I'm just gonna get rid of it, and by trial and error, of course, you have to figure out what line you can get rid of. And so now instead of the 1 step I took, I'm gonna say let's take 500 steps. Okay, so and this way I can control how many iterations and how often I want it to save, and what is the name of the simulation. You can also set things like your differencing scheme. If you want to center all the differencing or bounded, any option that Star has, you can put it in the macro and set it there. Okay, so but you just gotta go start a macro file and click away, see the file grow, and then decipher it after that and make it suit your whatever needs you have for the simulation. So I'm gonna save this file right now and quit that. And now I'm gonna show you really quick the job file. So this is the job file I also posted, and example of that, of something like this, is on the CHPC website. So if you go to chpc. Do you have a? Yeah. So. And Milo knows where that is too. And you click on badge over here, and if you scroll down, and it basically explains how to do how to create the batch script. So here is example of the batch script, and this is how you should do it, and this goes along the lines that Charles was discussing on Wednesday, that you never want to run from your home directory if you're going to output a lot of files. So what you want to do is create the directory in Scratch, and for your specific username, and then for your specific job. So this will actually fill out the appropriate. So this is a variable, so it will fill out your appropriate data based on the job. Yeah, and then you cd to the directory, then you copy from your home, from wherever your working directory and data file, so you'll need to provide the paths here. You copy it to Scratch, and then you execute it, and one thing is going to be different for Star, and then you copy the files back to your home. Okay, so this is how it should be done, and this is how you should use it if you output a lot of files.
Just one note, it shouldn't be Scratch General, so since we're in the Uinta group, we should be using Scratch Uinta.
Yeah. Thanks.
Sure. There's a little more space there too. So.
So I put command. So you can take this document from it's under the Scratch, Uinta, Michal, starccm batch files. So you can go there and you can copy all these files and use them and change them. So these are the PBS headings, and I have some settings over here. So the 2 nodes right now, 8 processes per node. Then right now I'm gonna request only 15 minutes of computational time. This is just really quick. Maximum is 12 hours. This is the -A Uinta group. You can also specify the QoS, quality of service flag, that Charles was talking about on Wednesday. And then in the example over here, they also have these 2 things. You can specify if you want the mailing, so it will send you an email if your job gets submitted, and sends you an email when your job gets finished. So it automatically will notify you. It can notify you. And then there is n number, a job name here, and this is very important for me. This is one thing that I always like to set, and it's not set by default. It's the PBS -J. It tells you to join, and O means output and E means error. If you don't join them, it will create 2 files while your simulation is running. It will create an output file and it will create an error file. However, if you have a bug in your or like multiple bugs in your case setup, it will give you one file for output, and it will give you, and then the system error files, system error messages will go into this error file. But you are not able to say where along the output file did these error messages occur. So what I like to do is I'd like to join them, and when I join them, it does the output, and if error occurs, it throws in the spot where it occurred in the output file. So therefore, oh, I went and the system error occurred because either my temperatures diverged or something of that sort. So this creates one file and puts the error and output together. So, and I would strongly suggest, especially for debugging purposes, use that setting. Then the next thing in this file is the nmax4, and this is right now on the current cluster. As I mentioned, it is fastest to use. It's faster to use 4 processes per node than 8 processes per node because of it seems like the memory management. But this is how it is right now. If there is no way around it, there are jobs that do. I mean, there are applications that do this all the time. That sometimes it's not worth running on 8. Sometimes it's better running on 4. It's unfortunate because you waste 4 processes per node.
Or you can run 2 cases. Take 4 processes from each node.
Well, that won't take. Yeah, that would be ideal, but you can't do that. Yeah, because the one that node doesn't let you. You have to request all 8 to use 4, so it doesn't let you use the other 4.
Run 2,
no,
and you can't specify processors within a node. You just have to say it's sort of a hatchet.
Yeah, it usually dumps whatever process is idle. It will dump the computation to it. But
what I mean is in your machine file, it doesn't say which
which
processor,
core.
It just says which node.
Yeah, it just gives you a list.
Yeah, so
but you have to specify 4 times that node, correct?
Mm-hmm.
Yeah.
So in your other simulation, you can specify 4 times that node, and those will immediately go to the idle processes on that node.
Well, it would be nice, but then we can do that. It's not.
It will not.
Sorry?
We don't have a way to.
Yeah.
He was saying something. Can you repeat, Ansha?
Yeah, I was saying to Tony that it will not go to the ideal. Yeah, I was saying that that 4 process, if you submit another job, that will not go to the ideal processors because there is no way we can we can just indicate which processor is idle and which is used.
No, it's the job of the operating system to take care of that.
Machine file will not know.
Yeah. So
that's what the machine file tells you.
Which phone you are doing.
Yeah.
They all are same, like just the name of the node.
And the other thing, you will never get to that point because the scheduler will never let you double occupy node. So.
Is it because of the PBS system submission?
No, it is right now. Most likely, it is because of the memory management on the cluster. So this cluster is fairly old that we are using. So you can just the memory management doesn't allow that. It allows it to run on 8 you can run on 8, but it decreases your performance by about 25%, I noticed. So you are better off running on 4 than 8. That's it. That's how it is, and that's for now. That's what we gotta do if you want to run it. So right now there is no other way around it on our system because it seems it's hardware limited. It's not software, but it's hardware limited. So
If you submit a job in that conditions, are you affected by the scheduler there? So it's if you're waiting for a node in a
queue, yeah.
eligible jobs, the administrator said, okay, this is just requesting 8 nodes, and this person is just requesting 4 nodes, so the priority is for the 8 nodes.
Okay, so this is this is one of the other things on Wasatch on Updraft. Sorry, Wasatch is our cluster in Logan.
That's your hiking.
Yeah, well, no, that's actually like in Logan we have Wasatch cluster and Uinta cluster. So, but on Updraft, if you specify you want 4 processors per node, which would alleviate the problem with the node file that you're gonna have, it will never let your file to go through. It will never let your job to go through. So if you specify 4, you can wait till
Forever.
allocation comes and goes, and you'll be waiting. So you have to specify 8. Okay. And the scheduler will just not let you run on 4. If you want to run on 4, they tell you to run on Sendunarj. If you want to run on Sendunarj, good luck. Okay, it's a lot slower than Updraft. So you specify 8, and this is the variable nmax4 that. Is he taking a shower?
It's raining, or he has a local weather system in his home.
Yeah. Just if you want to ask for a performance, you just use 4 over here, and then here is the final sim. So this is the file it's going to read. This is what you set the name to, and here is the macro, the name of the macro file. Then you need to specify, and then you need to change this based on your simulation. Then you need to make sure you change the path. So this is going to cd into the Scratch directory, and I'm running directly from the Scratch. I'm not running from home, so I'm not copying any files. And this command basically shows all the nodes that are in the node file, and so it shows all the nodes that are in the node file. However, for starccm, it's going to list 8 processes per node. And right now, it's not, it's a performance hindering if you run 8 processes per node. So we need to make sure we change this file to 4 processes per node. So it would be much better if if we could specify this, it would automatically generate the correct node file. But we can do that. So what we have to use, and this is where this is fixed. This node.file.all. Damn.
Oh, they killed your job.
Yeah, I requested 30 minutes. Yeah, so I killed myself. Doesn't matter. Yeah. So back to this. So over here, it dumps it into this node file. So this is the actual name of the file. It dumps the list of all. So basically, if you request 2 processors and 8, in this file you're gonna have 16 lines. You have 8 list. The one node is gonna have 8 list itself 8 times. Another node is gonna list itself 8 times for each core. So then I wrote this quick macro file, and what it does, it takes this node file, and based on your nmax over here that you set it to 4, or if you're gonna run on 1, if you're just gonna run it on 1 core, then set this one to 8, because on 1 core you don't have that problem. Oh, sorry, 1 core, I keep throwing these terms around. 1 node. But if you are running on multiple nodes, you wanna have that set to 4. Okay, so, and this one works for 4, 8, and you don't need it if you're gonna run on all 8 processes. So this macro file takes that 4 and basically reads in, finds out what nodes you are using, and then it creates a new, based on this file, it finds what nodes you are using, and it creates a new file that you're gonna feed to star over here. So this is the machine file you're gonna feed to start. So we create this macro creates out of this file, changes it to that file. Okay, so these are the fixed names. Then you find out from based on the file it created, it finds out okay, how many processors you are using. So it sets the variable based on counts the number of lines. Then it displays it into. You can disable this line if you want to. I like to have it displayed so I know for debugging purposes if there is a hardware error. This may let you know, okay, if you consistently get error on some nodes and you don't get it on other nodes, you may know that there is some interconnect wrong on some nodes, so this may help you find out what the nodes are. Then you export your environment. So it exports your aliases in your bashrc file. And then this is the command that will help you, that will make that executes starccm. I have a path set for starccm, otherwise you will need to specify the whole /uufs/chpc.utah.edu/ the whole thing. So I have a path variable set, and if I didn't have this command, the path variable wouldn't be recognized. And then these are the defaults. So power gives the let's to use the power license, and -np is number of processors. And these n slots come from number of lines from the node file, so it tells you that I want to use 16, or in this case it's going to be 8, because it's 2 times as 16, but we can use only half, so it's 8. And then it says, oh, the machines that I'm going to be using are stored in this file, and I'm going to be using badge, and this is the macro file, and whatever variable you set over here, so here is the macro, it's going to use that file, and it's going to read simulation file as it is specified here. Okay, so that's all.
Sorry.
Uh-huh.
When you go again through
Dam. I mean the Hoover Dam, not like a dam with an N. Yes.
When you go again through the export path, where's that PBS all path?
Oh, that's your default path, and this is the. Anytime you launch a job, it creates this node file. Where is the node file? Cat. You see this variable PBS node file. So anytime you launch a job, it creates a new sets of variables.
Okay.
So what you are doing with this command, and this is a command you just have it there. You don't touch it, and you don't need to change anything. It will automatically export path from your home directory on the node you are running. So you need to set up the environment on the node that is currently the master node is gonna launch your job. So what this does, and you don't need to do anything, it exports the path into this path. I mean, so it's available for the PBS scheduler, so it knows what, so you know what it can use your alias, not alias, it can use your paths that are set up in your bashrc file. Okay? So you don't need to do anything, you just leave this one, you don't touch it.
Okay. They say
You can have it or you don't have to have it there.
they say in the web page that you have to set a path for these jobs in parallel for MPI, MPR, MPI that thing. So I get a little, I was confused about that.
Oh, okay.
When I was creating mine, I didn't know if I have to modify the path, add this path to my bash profile, or just put it as it was. I tried as it was and it works. I don't know.
Okay, so you can do it as it works. If you try it as it is, did you define your path in your home directory and it worked?
No, actually I just defined all my paths in the script.
Oh, okay, yeah. So
this will going to source your bash profile.
Yeah.
It doesn't know about your bash profile.
Yeah, but they say, for example, in the last lines of this, he adds something like.
Where there?
Oh.
There.
Oh yeah, machine file node.
I am.
Batch,
Yeah.
Okay.
Because I'm using, you see this variable already.
Yeah.
So that one allows me. The system only allows me to run it because I have this PBS of path.
Yeah.
If I didn't have that, it wouldn't recognize the command.
You have to specify
The UUFS, yeah. So you can get rid of this. You don't have to use it, and I would encourage you to experiment with it, and try different things, try errors, and
Okay, yeah. I think I do it with all the way. So I just
So you can.
all my paths in the script. So
Okay, you can try this and see if it works. You know.
When
but-
in doubt, specify the whole thing.
yeah, specify whole thing all the time, and
Then
it,
it can't get lost.
yeah. Okay, so that's the file. So right now, we are pretty much ready to go. And to submit a job, so the final simulation file has been set, the macro Java has been set, Annulus job, you need to specify the correct path simulation file and the macro file, and now we can just run. So to submit a job, you just do qsub and the name of the job file. So I just do qsub annulus.job, and it gives you the number. You do qstat, and oh yeah, I forgot to change the name, but job name here, that's the name. Okay, so you can change it in the. Oops. Oh, what is it called? Yeah, over here, the job name here, just put in whatever you want in. Okay, so don't, yeah. So, and now when you look at it, it says, oh, it's running. So if you want to check on how it is running, you can go to your home directory, and under this directory, it's dot directory, so it's hidden. Where is P? Oh, here it is. PBS spool. In that directory, you're going to have output of the file. So if you go to cd pbs spool, it's going to give you the status of the job number. So right now, it's over there. So I'm going to use the, can you wake up, Ancha? Tail function. Is it still there? No, yeah, so the job already finished because it was so short. Yeah, and it has the C status now. It had the R status. R status means for run, Q for queue, C for completion, H for hold, and there's a whole bunch of them. So right now it's still completing, but it created the .o file right here. Okay, so if you look at this file, and this works for any application. So right now the difference is we launch star with that command in the annulus.job file. You can launch your Fortran script. You can launch your any script. You can launch anything with that. You can launch stuff. So you don't have to just launch the starccm. And it's still using the non-blocking. Even on 4. So, but right now it says it used 238 and nodes 252 in the for the job, and so this is where star starts running, and it reads in the file. It reads it in right here, and starts iterating. So you actually can see the residuals for this file, and then we specified every 100 iterations we want to save the file. So it auto-saved it over here. Okay, so it created the final. Oh, did I call? I didn't. Oh, that's what I forgot to do. Set the name.
Is each process saving?
Yeah. So, yeah, they save the whole simulation state. Yeah. So they all communicate to save it, and they save it together. Yeah, well, I don't know how the specifics,
but one
but
file.
Yeah, it's one file. Yeah. Not like OpenFOAM, for instance, is one of those that creates 8 files.
So this thing autosave is just a signal, it's just a print statement that this process is sending the data to the
so it's
so that
exactly. Yeah, so it doesn't create 8 files; it creates only one. Yeah, so it goes and it saves the files every 100 iterations, and at the end, it saves over here the final sim.
In the end, you will have just one file.
You will just have one file. However, I forgot to set this in the autosave settings. You can specify the name of the file, so it is different from the final. So what I'm gonna do for a second job, really quick.
Would that like a time step number?
Yes, you can add an iteration. So time step adds and automatically add 9.4 e-1, so it adds a time step. And
If I have a very long job, can I just check on inline? So every iteration, can I check every iteration while this job is running?
You can check. So I'm gonna show you right now because it made it quick. It completed really quick. So one thing that, so I'm going to edit the macro file, and I'm going to say, okay, save every 100 time steps, but let's do 1,000, let's do 2,000 iterations. 2,000 iterations, and I'm going to save every 200, and I'm going to call this file final sim file, and I'm going to leave the final.sim to be the in-between saver file. I think it should work that way. I'm just trying to see because well, let me do, and this is how you test it. You just try it. So I'm gonna save this guy, but now I have to go and change it in the so I'm basically copying the file to a new file, and in the macro file, oops, not in the unused file, I'm gonna change the name of the starting file to be file sim. Okay, so now I'm gonna submit this again, and I'm gonna just qsub annulus.job, and it submits the file, and let's see if it starts running. Yeah, so it starts running. So right now, edit is job 3310059. So it creates this file right here. Okay, so now what you can check on it, you do tail -f 310059, and you can follow it interactively what it is doing right now. And tail function specifies the last 10 lines, I believe, of the output file, or you can check the manual to make it something else, or you can just do nedit or do vi that file, and it shows you what it is right now, and then before it will give you a warning that this file has been updated, but you can see what it does. So another trick that I always use, and this is where once you figure out how many iterations you want to, in 12 hours you want to run as many iterations as you want. Okay, so once you request qsub, you have 12 hours. You want to use those 12 hours effectively. If you finish in 6 hours, well, there may be some other job, so you can have two jobs, 6 hours and then 6 hours. But what you want to do is have one job use as much of the 12 hours as you can. So basically, after it terminates, if there is another job waiting, you used as much time as you can. So instead, if you had a 6 hour, if your job finished in 6 hours and you requested 12 and you were waiting to get that 12 hours, you submit a 6 hour job and then you submit a subsequent 6 hour job. It may take you longer to run 2 6 hours job than one 12 hour job, because you want to use the whole cycle, because then you have to wait for other people and share the stuff, and but if you use a full 12 hours, there is one command that the qsub that I always use. It's qsub -w depend, and I never seen anybody running it this way on this cluster. So what I just did is I submitted another file, qsub another job that depends on the previous job. So now, but this works only when your initial starting file name and your ending name are the same. Also, it saves the final.sim. It saves it as the name of the final file. It doesn't save it as with the iteration. So what this guy does when you do qstart right now, it shows, oh, you see it's completed right here. So the one job completed and the next job already starting automatically after that. So after 12 hours, you want to have another job. So right now I can do this, qsub after 60, it runs. Then I do 61, then I do 62. And so right now I have one job, and then so let's say if you want to run for 20 seconds, you want to run something for 20 simulation seconds, not 20 seconds here, but for, let's say you need to run a simulation for 100 hours, but you can run it only in 12-hour blocks. So this case, I do 12-hour block, and then next simulation file reads in the final.sim file, reads it as an inlet, as a starting file, iterates on it, saves it as a final file, and then the next simulation comes and says, oh, I can start from this final.sim. It reads in the file, which basically takes off from wherever the last one. It takes off wherever the last one left off.
It picks up where the
picks
last
up,
one
yeah,
left
thank
off.
you. Picks up here where the last one left off. So in that case, you can run. In that case, you can run a whole simulation without ever going back and doing anything. So this is the most efficient ways to get your jobs through. So like let's say Anshul is using this a lot. If he wants to run a 5-second simulation, but he can use only 0.005. He can run, let's say, 1,000 time steps or 100 time steps within 12 hours. He can submit 10 consecutive jobs, depending one after another, and so you see, so it's running that guy. So, and then he never has to come back. He just keeps running, doing anything it wants, and you basically go on vacation. You come back, and your simulation is done.
So,
assuming nothing crashes.
So let me understand. So this instruction takes the same job and running in serial mode every time it finished the
previous job.
Previous job, but the previous job is the same.
Yes. Well, it iterates. It is the same file, but what you see, like this guy, this final sim file.
Yeah.
It's 1459 right now. The first time we ran it was 1449. So this file is constantly updated. So
Okay.
it saves you. You go so many iterations, it saves that file. Then you go more iterations, it oversaves that file. So right now you are left with the most recent file solution, with the most recent solution.
Okay.
So as you submit more and more job, it keeps rewriting itself, but you are stepping further in time.
Oh, that's good.
So therefore, so like when you look at these statements right here, so I'm gonna do an edit.
So like if you were writing a book, you would only write it one chapter at a time. This is basically saying, put this chapter after this chapter, and then that chapter after that chapter, rather than saying, okay, overwrite each chapter.
Yeah. So you can look at it this way. We started at zero iterations. Okay, one iteration, like the first step, I did for when I was setting up the simulation. So the next job ran from 102nd iteration to 599th iteration. The next job after that, 59, ran from hopefully 600 or 602. Well, there were other few more after the when it saved. So 600 iteration all the way to 2599, and actually here it puts the other two iterations. So 2601. The next job, the 60th job, so that was 59. The 60th job goes from 2602 to whatever, till whenever it needs to, and then you specify till 4601. So it takes and goes one after another. So if you check on the QStat again, see we had 3 jobs there, so now so it took the second one and just basically runs it down like this. So if you want to have 12 hours, like I said, this is the best time if you go for vacation. Just set everything up and let it go, and you can go on vacation. Okay, and people think you are running. So exactly, and all you do is just your jobs are always in the queue and you are not there. That's what you want to do. I mean, that's what we do. This is recorded, isn't it? So anyway, and there are other. So for the Q sub minus W, if you do man Q sub, the man command again. Sorry, there is no woman command. They should have one, to make everything look tidy and illogical. And and you can specify different things. So I specified the minus W option. Oh, it's right here, additional attributes, and it's the dependency list. So I specify after OK, and you can do after okay, after not okay, after any, just in case, let's say your job crashes in the meantime, like there is a power failure at the center over there, okay? So your job crashes, what after okay, where the one that I used, on this one, it only lets your simulation run if it receives okay signal from the previous iteration. If it doesn't receive okay signal from the previous iteration, it will never go. So sometimes if there is an error or power outage or something like the jobs just crash, you will see all your simulations in the, you see your like H simulations, but there is no R simulations. Okay, so that means basically your jobs are on hold indefinitely because the master has been killed. So this is a very Japanese type of running. Isn't it how it works in Japan? You killed and during the samurai times, you know, like when they killed the master, the other guys just call the what is it called? Seppuku. Yeah, seppuku. Yeah. So these guys are just on hold. Yeah, right. They don't kill themselves, but anyway.
They don't commit
Yeah, they don't
job
co-
seppuku.
Yeah, so you have to actually. So in that case, you just go and do the QDEL, and you can kill any job. You can QDEL. Feel free. You can kill only your jobs. You never can kill somebody else's jobs. Okay, and more help on running star. You can always do star ccm -help. Okay, it gives you all the things, and if you want to have more on help on more in parallel, if you do star ccm -p help plus -p help, it will give you the parallel settings where you can test it, and you can use different. Well, we use PBS. Our cluster has a PBS scheduler, and you can do a whole bunch of flags and different interconnects. I would say stick with the default. So you can customize it based on that. And I'm sure any other program has the same thing. So I would suggest to use that H file, and you know, the H file, the minus capital would depend, and they're good to go. So and you can try it, and if you have any questions, let me know. Okay, so 5 minutes turned into hour and hour. Sorry to take your time. Thanks for staying awake. Yeah, Anshu, I think Anshu, yeah, go on.
He left, yeah.